we are going to discuss the concept and topic of stars suitable for observation. Now, this particular method, stars suitable for observation, is used to ascertain or find out which stars will be suitable at the time of twilight for a particular observer if he wants to use a specific method of sight or a specific method of observation like meridian passage, marpas or latitude by meridian altitude, or X meridian. So basically this means that if a observer wants to take a star sight at the time of twilight, twilight is the only time when a star sight can be taken. So he wants to take a star sight, but he wants to use a specific method. He wants to use a particular star for meridian passage or for a X meridian sight. Now, how to find out of so many stars which are visible to us in the sky, which of them are suitable for the Marpas observation or for the X meridian observation? That is the meaning of the topic, stars suitable for observation. Now, before we go into this topic, we need to understand a few basic concepts to familiarize us with the method and procedure which we use to determine which stars are suitable for meridian passage or X meridian. Now we understand that only those stars will be suitable for a Marpas observation which cross the observer's meridian during the twilight time. Meridian passage sight is taken at the time of the celestial body crossing the observer's meridian. And if we want to use a particular star for X meridian sight, we are aware that that particular star should be within the X meridian limit. So we need to check the X meridian limit for the observer for that particular body, and we need to make sure that the particular star is within that X meridian limit to be suitable for a X meridian observation. Now, the basic topics which we need to understand before we jump into this topic are number one, the concept of stellar magnitude, and number two, the concept of twilight. So we are going to understand these concepts one by one. Let's first go into the concept of stellar magnitude. Stellar magnitude is a scale used for specifying the apparent brightness of a star as observed from the Earth. The magnitude number decreases as the apparent brightness of a star increases. You can see this diagram showing some specific celestial objects, celestial bodies, and also their stellar magnitude. You can see the brightest object in the sky which we have is the sun, and it has a stellar magnitude of minus 26.8. Now, as I told you earlier, the magnitude number decreases as the apparent brightness increases. So the celestial body having maximum brightness is the sun, and it has the minimum magnitude number. The magnitude number of the sun is minus 26.8. Now, after the sun, we have the moon, the second most bright body in the sky, and the stellar magnitude of the moon is minus 12.5. Then after the moon, we have the planet Venus. When it is at its brightest, it has a stellar magnitude of minus 4.4. Then we have star Sirius having a stellar magnitude of minus 1.5. Then Alpha Centauri, the nearest star to us after the sun, having a stellar magnitude of 0.0. Then Betelgeuse 0.8, Polaris 2.5. Now the limit of the naked eye is stellar magnitude 6.0. These stars with magnitude 6.0, very faint stars, barely visible to the naked eye, are the 6.0 magnitude star. They are also called as sixth magnitude star. The brightest of the stars which we have, like Betelgeuse, Alpha Centauri, Sirius, they are called as the first magnitude star. So faint stars, barely visible to the naked eye, sixth magnitude star, and the brightest of the stars coming under the first magnitude stars. Now, if you go little more further, if you use a binocular to observe the sky, you would be able to see the stars having a stellar magnitude up to 10. If you have a 1 meter telescope, it can help you to see the stars up to a stellar magnitude of 19. Then another important telescope which we have, Hale telescope, can see the objects having a stellar magnitude of 27. And the most powerful telescope which we have, the Hubble telescope and the Keck telescope, they can help you to see the stars, celestial object with a stellar magnitude number 30. So a diagram giving us a comparison of the brightness as well as the stellar magnitude of different celestial bodies. Now, a first magnitude star is 100 times brighter than a sixth magnitude star. We can also calculate, if we have two celestial bodies, their stellar magnitude known to us, we can calculate how many times a particular celestial body appears brighter than the other celestial body. We have a formula which can be used to calculate the relative brightness, and that formula is relative brightness of a body compared to another celestial body is equal to 2.51 raised to power x. Now, what is x in this formula? X is the difference between the magnitudes of two bodies which are being compared. So if you are given two celestial bodies, their stellar magnitudes are known. You can find out the difference between their stellar magnitudes. 2.51 raised to power that difference gives you how many times a particular body is brighter than the other.
Now you can try out this formula very easily, beta. This is 2.51 raised to power x. So if you want to compare a first magnitude star with a sixth magnitude star, what will be the difference in magnitude here?
.51 raised to power 5, sir.
Very good. So difference is 5. 6 minus 1 is 5. So just do 2.51 raised to power 5 in your calculator, and we can check whether this shows 100 value or not.
99.625.
Great. So you round it off and it goes to 100. If you want to go more deep, this factor is basically 2.512. But as far as our accuracy is required, for our accuracy 2.51 is enough. So this formula gives us a method to compare the brightness of two particular celestial bodies.
Now we have seen the stellar magnitude of the stars. We know that the faintest of the stars are of magnitude 6.0 and the brightest of the stars are magnitude 1 star. Now these stars are categorized basis their brightness. We have put them into categories. Now what are these categories? All the stars having their magnitude less than or equal to 1.0. That also includes the star in the negative stellar magnitude range. So all the stars having magnitude less than or equal to 1.0 are called as first magnitude stars. This is a group of the brightest possible stars in the sky, and they are the most preferred stars for the purpose of sight taking or for the purpose of observation. We always prefer to have a first magnitude star for our sight taking purpose. They are the easiest to spot in the sky, being the brightest. Now, stars having magnitude greater than 1.0 and less than equal to 2.0 are called as second magnitude stars. In case you are not able to find a suitable first magnitude star for the purpose of sight taking, you can also choose and pick up a second magnitude star. They are also bright enough to be used easily for the conveniently for the observation. Now, after this, stars having magnitude greater than 2.0 and less than equal to 3.0, they fall under the category of third magnitude stars, and so on. 3.0 stars having magnitude greater than 3.0, less than equal to 4.0, fourth magnitude. Stars having their stellar magnitude greater than 4.0, less than equal to 5.0, fifth magnitude, and so on. Now, why are these categories important? Because in the questions, they sometimes ask us to find out the first and second magnitude stars which are suitable for a particular observation. So in that case, we check their magnitudes from the almanac, and whichever magnitudes fall under our required category, we pick up those stars and write them as our answer. Now, going further, we need to be familiar with the stars information table given on page number 268 of the 1992 almanac. Let's have a look at that table. We have the left-hand side page of the table. This is page number 268 of the almanac. And now you can see on the right side is the right-hand side page of the stars table. That is page number 269. Now this table gives us the required information about the stars. The first column which you see gives us the magnitude number of each of the star. The second column gives us the name and number of the star. After this, you see the next column of the table gives us the SHA and declination of the stars from January to June. For the first 6 months of the year, the SHA and declination is given on the left-hand side page. You have the SHA given first, later on followed by the declination of the star. Now we are aware that the SHA and declination of the star does not change much. There is a very minute change in the SHA and declination of the stars. They can be practically assumed to be fixed bodies on the celestial sphere. So that's why you see in this particular table, the degree values of SHA is mentioned in the beginning, and the minutes are mentioned under each and every month. Now the change in SHA, what happens is happening only in the minutes. The degrees usually do not change. So under every respective column of the month, you see the minutes value is given. So you pick up the degree value from the first column, and then you pick up the minutes value from whichever month you require the value for. The same is done with the declination. You see the degree value is given initially in the first column, followed by the minutes value for each and every month. And you can see here that the value changes by a certain minutes every month. The change is very, very gradual and slow and not very significant. Now on the right side of the page, we have the SHA and declination of the stars given from July to December. So the right side page gives us the required information for the last 6 months of the year, July to December. You have the SHA and then followed by the declination. Again, the same format is used. Degrees are given in the beginning and number of minutes are shown under each and every month. Now the stars are listed in this table as per increasing order of their SHA, sidereal hour angle. You can see the stars starting in the table from 000 SHA going up to 360 degree SHA. So the first stars which you see is 5 degree SHA, the next one 13, 14, 15 and so on. So if you want to identify or pick up a star from its SHA value, this table is very convenient to use. You can enter into the SHA value column and whichever SHA value you require, you can identify that particular star from this table. Now the left side page of the table gives us the Latin names of the stars. The names which are mentioned here in this particular column are the Latin names of the stars, along with the SHA and declination from January to June. Whereas the right side page which we see gives us the English names of the same stars. And also, as we discussed just now, it gives us the SHA and declination of the star from the month of July to the month of December. So important thing to remember here is whether you go to a particular star on the left hand side page or you go to that particular star on the right hand side page, it is the same star mentioned. Only thing is the names given on the left side page are Latin names and the names given on the right hand side page are English names. To give you an example, pay your attention to the number 2 star which we have on our list. On the left hand side page, you see the number 2 star which we have is Alpha Pegasi. Whereas if you go to the right hand side page of the table, the same star is mentioned as Markab. So on the left hand side, Alpha Pegasi, on the right hand side, Markab represents the same star. Alpha Pegasi is its Latin name and Markab is its English names. Now, as far as our exams are concerned, we always use the English names of the star. So whenever you are required to identify and list down the stars, you will be picking up the English names, irrespective of the month of the year, whether it is January or June or July or December, any month of the year, you will be picking up the names in English. That means the name from the right hand side page of the table. So if you are picking up the second star, even for the month of January, the star will be named as Markab and not as Alpha Pegasi.
Sir, can you repeat, sir?
Regarding the names, beta?
Yes, sir.
Okay. Beta, what I said was that on the left side of the page, these names which you are seeing, these are Latin names. And on the right side, the names which you are seeing, they are English names. The star is the same. Like number 2 stars, Alpha Pegasi is its Latin name and Markab is its English name. The star is the same. So what do we use, whether we use Latin or English for our purpose? In India, we always have been using the English names of the stars. So when you write your answers in the examination, you pick up the English names only, means the names which are given on the right hand side page. Is it clear now, beta?
Yes, sir.
Okay. So even if it is the month of January or February and you are looking for number 2 star, it will always be Markib. Don't get confused that on the left side page for January month its name is Alpha Pegasi. No, it's not like that. The name Markib and Alpha Pegasi means the same star. Okay. Gangadhari Shaktiman hai beta.
Yes, sir.
सही बात है.
Okay, right? So now I hope you understood. Okay. और बेटा और कोई डाउट टेबल में बताओ.
सर करना क्या है इसके बाद
सर
सर?
एक तो ना सर वो की जो वेरिएशन बताया था सर आपने, जहाँ पे एरो बना है अप एंड डाउन का, उसका रीजन क्या बताया था सर आपने? द मैग्नीट्यूड.
Can you ask again, beta?
So the some stars have the variable magnitude, no sir? On the bottom of the page, they have mentioned 3.7,
Okay.
3.0.
I got it. Okay. Now, what he is asking is that if you look at the magnitude of the stars, then at some particular stars, you could have a special sign, a double plus sign or something else. Instead of the magnitude number, they will give you a sign here. Now, if you go to the bottom of the page, you will see that against the sign, they will give you a range. So can you see the range better?
Yes, sir.
So what is the range they have given for that star?
3.0 to 3.7.
Very good. So whenever a special sign is mentioned in the magnitude column, you go to the bottom of the page. There you will get a range, and that range basically means that the magnitude of this star is variable. The magnitude of this particular star is variable, it is changing, and it could be any value between these two ranges. If it is 3.0 to 3.9, that means the magnitude of the star could be of any value between these two figures. This is the meaning, beta.
So my question was why it is variable, sir?
Very good. Now we are going deeper into it. So अब बेटा दिमाग लगाओ, कौन बनेगा नेविगेटर? कि स्टार का मैग्नीट्यूड वेरी कैसे कर सकता है?
सर विजिबिलिटी की वजह से, डिस्टेंस की वजह से.
ओके, पर बेटा एल्मनैक तो बना है ईयर के बिगिनिंग में. हाउ डू दे नो द विजिबिलिटी ऑन ए पर्टिकुलर डे एंड इट विल कीप ऑन चेंजिंग डे टू डे? ये टेबल तो फुल ईयर के लिए एप्लीकेबल है. राइट और अगर विजिबिलिटी खराब होगी तो सारे स्टार ही डिम हो जाएंगे. तो सबकी मैग्नीट्यूड वेरिएबल होनी चाहिए, इजंट इट?
उस स्टार्स की एज के ऊपर है, कितना एज है.
से अगेन बेटा.
स्टार्स एज आपने बताया था ना, एज से होता.
राइट. यस, वन ऑफ द
वो
फैक्टर्स.
डिमिनिश होने के बाद भी दिखता रहता है कुछ इयर्स तक.
That's right. So one of the factors could be the age of the star. Like you see, sun is now in its adult age. It is slowly going towards its old age. Okay, sun की age बहुत ज़्यादा है compared to us. So after a certain time, the sun is going to blow out. Okay, sun is going to finish off. So when it is going towards its old age, the power or the brightness, the nuclear fission fusion reaction which is happening, the amount of gas, fuel which is present in the sun is going to reduce. So slowly its brightness is going to come down. First, it is going to increase. It will increase so much that the temperature will be so much that all the water on the earth is going to evaporate, and then we will not have life anymore. This is one of the reasons why Elon Musk is venturing into Mars. Huh? Do you know about him, SpaceX?
Yes, sir.
Yes, sir.
So this is one of,
वो
Yes,
मार्स
sir.
से भी पार हो जाएगा, जुपिटर जाने से.
so right now he is aiming for Mars, but let's hope when he makes it, he settles down there and then he makes plans to go further. So anyway, so you see with the age of the star, its brightness could change. This could be one of the reasons. Okay. But this phenomena happens after a very, 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 very long time. Like for the sun, it is going to happen maybe after some billion years or something. So
अगर एज मैटर करता है सर, so the brightness is going to be कम हो जाएगा.
ask
अगर
again,
सर
beta. You got
if अगर स्टार्स का एज बहुत ज्यादा है सर, so उसकी ब्राइटनेस कम हो जाएगी.
yes, that's right.
तो ऑन दैट एसएचए उसके उस दैट एसएचए एंगल पे सर इतना वेरिएबल एट उसी दिन कैसे दिखेगा हमें? मतलब कि उतना ही कैसे मालूम पड़ेगा कि इतना वेरिएबल हो गया आज?
Okay. Number one, beta, this variation is not over a day. This is for the full year. ये जो table है ये full year के लिए है, right? And number two, you are right कि एक साल के अंदर अंदर स्टार में इतनी वेरिएशन तो नहीं आ सकती कि एक साल में कोई स्टार खत्म हो जाए. Okay, that's too less a time. It takes thousands of years for a star to die, for a star to be born, and for the life cycle of the star. So most of the time, there could be any other reason for change in change in the magnitude of the star. दिमाग लगाओ.
Sir, it may be obscured by satellite. It may be obscured by satellite.
Exactly.
आपने बताया था.
Very good, Manish. Very good. So that is the reason why the magnitude varies. Is there are so many celestial objects in the universe, in the space, that many a times it happens that one particular object comes in front of the other. Traffic बहुत ज़्यादा है यहाँ पे, okay, and but everything is so systematic that we don't see any accidents happening. So traffic बहुत ज़्यादा है. So some particular celestial object, if it comes in front of that star, it could be a planet, it could be a asteroid, it could be any other celestial body. If it comes in front of that particular star, the star may be partly obscured and it may lead to the reduction or increase in the brightness for a short period of time. So most of the time, I would say 99% of the time, that is the reason for the variable brightness or the variable magnitude of a star. Okay, beta, understood?
Okay.
Okay. Now again, this is not going to be asked to you in the written exams, but yes, certainly, अगर आपका oral लेने कोई navigation का teacher आ जाए, so then he may ask you this question, and if you answer it, function 1 clear. Okay. Okay. So shall we proceed ahead?
सर तो ये चाइना ने आर्टिफिशियल सन कैसे बना लिया है? तो
I have no idea, बेटा. अभी मून बनाया है उन्होंने, सन तो नहीं बनाया है, but I don't have any idea, बेटा. Okay, they say that they have created a artificial moon. How they have done it, I no idea about it. Anybody has any idea, beta?
चाइनीज है सर.
वो चाइना में दिखता है सर, और
दिखेगा कि नहीं पता नहीं.
पावर ऑफ
Chinese
फोर्स
moon
के लिए किया है सर. वो
पता नहीं.
नाइट में विजिबिलिटी कुछ ऐसा है उनका कॉन्सेप्ट, उसके लिए यूज
Some
किया.
funda like that, but I have not been able to understand the logic or how they have done it.
सर वो रिएक्टर लगाया है एक तरीके का, पर वही है सर, वो चाइनीज है, 2-4 दिन में हो जाएगा उसका काम भी.
Exactly. Right. Okay. So चलें बेटा आगे.
यस सर. सर उन लोगों ने उसको थॉट को ज्यादा डीपली ले लिया. चले तो शाम तक, नहीं तो चांद तक, चांदी बना दिया.
Right. Okay, let's move ahead then.
Let's now understand the concept of twilight. Now, twilight is the light received from the sun when the sun is below our horizon. Now, we receive the light from the sun when it is above our horizon, and we call that light as sunlight. But we also receive some light when the sun is below our horizon and close to it, and that is the light which we call as twilight. This happens before sunrise in the morning and after sunset in the evening. So as you can see in this diagram, the right side of the diagram represents the sunrise, and before sunrise for this particular period, the dark blue color sector which is marked here on the right side of the diagram represents the period when we get the twilight. And when the sun goes on the western horizon, you can see in the diagram, the sun going in the western horizon sets at this particular instant, and after setting, we keep on receiving the light which is called as twilight when the sun is in this dark blue color sector. So in this particular sector, we receive the twilight in the evening. Now, even though the sun is below our horizon, it still illuminates the upper layers of the atmosphere. Now, this happens because of the refraction and scattering principle. The light undergoes refraction in the atmosphere and it gets scattered in various directions, because of which we are able to see the light even after the sun has set or the sun has gone below our horizon. Now, in the evening, when the sun sets, till the time sun is there in the sky, we receive the sunlight. Now, after the sun has set, we do not have any sunlight. What we receive now is the twilight. The twilight is available to us till the time the sun goes 18 degrees below our horizon. So you can consider this 18 degrees as a negative altitude of the sun. Till the time the sun is within 18 degrees of our horizon, we keep on receiving this twilight, and after the sun crosses this 18 degrees belt, after that there is total darkness and we do not receive any light from the sun. So in the evening time, the twilight commences at sunset, and it continues up to the point where the sun is 18 degrees below the horizon, and after that the night starts. So after 18 degrees, there is no light which we receive from the sun. It is totally dark. Now, in the morning, the twilight commences when the sun is 18 degrees below our horizon. It reaches at a point when it is 18 degrees below our horizon. That is the period when the twilight starts. Right now, the laser pointer is showing that instant when the sun is 18 degrees below the horizon. We keep on receiving this twilight till sunrise, and as soon as the sun rises, the twilight ceases and we are able to see the sun and receive the sunlight. Now, this entire period of 18 degrees is divided into 3 different stages, and we call these 3 different stages as civil twilight, nautical twilight, and astronomical twilight. Now let us see these 3 stages of twilight one by one. Now we have zoomed into the right side portion of the diagram depicting the sunrise. Now you see the sun is at this instant at a particular time, As the sun approaches towards our horizon, right now it is night, it is totally dark. We are not receiving any light from the sun. Now, when the sun reaches at this particular point, you can follow the laser pointer on the screen. When the sun reaches at this particular point, now this point is 18 degrees below the horizon. You can see the angle also mentioned here. The sun has reached 18 degrees below the horizon. Now, this is the instant when the astronomical twilight commences. The astronomical twilight has commenced at this particular instant, and we are able to receive some light, though very, very little, at this particular point of time from the sun. After this instant, the sun keeps on coming closer to the horizon, and the altitude it was initially minus 18 degrees when the twilight started. Now it starts to come down, minus 17, minus 16, minus 15, and so on. Now at this particular instant, the sun is 12 degrees below the horizon. You can see this angle is 12 degrees now. It is marked in the diagram. Now this is the instant when the sun is 12 degrees below the horizon, and at this particular instant, the nautical twilight commences. The nautical twilight has commenced here. After this instant, the sun keeps on coming closer to the horizon, and at this particular instant, you can follow the laser pointer. At this particular instant, the sun is 6 degrees below the horizon. The angle is shown in the diagram. And at this particular point, when the sun is 6 degrees below the horizon, civil twilight commences. Now, all these three twilights, they go up to the sunrise. Each of them, the astronomical twilight, nautical twilight, and civil twilight, lasts until the visible sunrise. Visible sunrise is when the sun's upper limb appears on our visible horizon. That's the instant we call as visible sunrise. So you see, the commencement time of all the three twilights are different. Astronomical twilight commences when the sun is 18 degrees below the horizon. Nautical twilight commences when the center of the sun is 12 degrees below the horizon. Civil twilight commences when the sun is 6 degrees below the horizon. And all three of them, they last until the visible sunrise, when the upper limb of the sun appears on our visible horizon. Now, out of this entire period, as far as navigators are concerned, as far as sight taking is concerned, which is the most suitable period for us? The most suitable period for us is between 12 degrees and 6 degrees. This particular period, which is represented in blue, the upper period is represented in light blue, and the bottommost period is represented in dark blue. The middle portion is what is important from the point of view of the navigator for the purpose of sight taking. Now this period is basically the commencement of nautical twilight to the commencement of civil twilight. The suitable period for us for sight taking starts at the commencement of nautical twilight in the morning, and it remains up to the commencement of the civil twilight in the morning. Now, why is this period suitable to us? If you go beyond this particular period into the dark blue zone, now in the dark blue zone, the sun is 18 degrees to 12 degrees below the horizon. With the sun more than 12 degrees below the horizon, there is very less light for the horizon to be clear to us. The horizon may not be very much clear to us because the light which we are receiving is very, very, very low. Now, as the sun reaches about 12 degrees below the horizon, we have sufficient light with which the horizon can be clearly seen. And we know for the purpose of sight taking, we need to have the horizon as well as the body in our sight. So we can start our sight taking at this instant when the sun is 12 degrees below the horizon. And this suitable period continues up to the sun going 6 degrees below the horizon. Now, when the sun reaches 6 degrees below the horizon, you see as it is coming closer to the horizon from 18 to 12 and from 12 to 6 now, more and more light is visible to us on the eastern horizon. Now, at this particular instant, when it is just 6 degrees below our horizon, there is so much of light on the eastern horizon that stars and other celestial bodies, stars as well as the planet, they start to disappear. So after 6 degrees, we may not be able to easily identify, find out the stars for the purpose of sight taking. It is so bright in the sky that the stars start to disappear. So this period is also not very suitable for us for the purpose of sight taking. The most suitable period is commencement of nautical twilight when the sun is 12 degrees below the horizon to commencement of civil twilight when the sun is 6 degrees below the horizon. Now we have zoomed into the sunset part of the diagram. This is the instant when the sunset takes place. So in the evening, as soon as the sun sets, as soon as we have a visible sunset, which means the sun's upper limb has disappeared from our visible horizon, this is the instant when all the three twilights commence. So the commencement time in the evening for all the three twilights is the visible sunset. The civil twilight continues till the time the sun is 6 degrees below the horizon. At this particular instant, the sun has gone 6 degrees below the horizon. You can see it is represented in the diagram also. Sun is 6 degrees below the horizon, and this is the period when civil twilight ends. The other two continue. The sun goes further down, and when the sun reaches at this particular instant, when it is 12 degrees below the horizon, so sun is at 12 degrees below the horizon here, the nautical twilight ends. Astronomical twilight still continues. The sun also moves down, and when the sun reaches at this particular instant, when it is 18 degrees below the horizon, the astronomical twilight ends. So we can clearly see that all the three twilights begin at the time of visible sunset. Civil twilight continues till the sun is 6 degrees below the horizon. Nautical twilight continues till the time sun is 12 degrees below the horizon, and astronomical twilight continues till the time the sun is 18 degrees below the horizon. After 18 degrees, there is no light received from the sun, and we have total darkness or the night. Now, in this case also, the suitable period for us for the purpose of sight taking is between 6 degrees and 12 degrees, which in this case is the ending of the civil twilight to the ending of the nautical twilight. This is the most suitable period for us. Before this period, the sun is within 0 to 6 degrees of the horizon, and there is too much light for the stars and planet to be visible to us. There is so much light that stars and planet may not be visible. Between 6 to 12 degrees, the light has decreased now. The stars and planets start to appear in the sky. They gain sufficient brightness so that we can observe them by the sextant for the purpose of sight taking. And after this interval, that means when the sun has gone below the horizon more than 12 degrees, there is so less light available from the sun that the horizon is not clear to us. The stars and planets are shining very bright, but the horizon being not visible, it will not be possible to take the sight. So again, the light blue portion is not suitable because there is too much light. The dark blue portion is not suitable because there is too less light for the horizon to be visible. The suitable period for us is the middle period, the blue color period, which is represented by -6 degrees to -12 degrees altitude of the sun. This is the most suitable period in the case of evening twilight. Now, be careful and be clear in your mind that in the morning, the suitable period was commencement of nautical to commencement of civil, whereas in the evening, the suitable period is ending of civil to ending of nautical. Now, practically, if you are trying to take a star sight, you need to be standby on the bridge wing ready with a sextant at this particular instant. That is when the sun is 6 degrees below the horizon. This is the instant when we are ready with the sextant on the bridge wing for the purpose of taking the sight, because this is the beginning of the suitable period for us. If we are ready here, we can observe the horizon also, we can observe the celestial body also, and a sight can be taken. If you are standby at this particular instant, that is ending of the nautical twilight, it will not be of use because the horizon is going to disappear now. So we need to be standby. This is the critical time as far as the evening twilight is concerned. That is the ending of civil twilight. Now, in the case of morning, the beginning of the suitable period is when the nautical twilight commences. Because in the morning, when the sun is coming from below the horizon, it reaches 12 degrees below the horizon. That is where the nautical twilight commences. At that time, the stars are visible in the sky, the horizon also starts to appear, and a sight is possible. So the beginning of the suitable period in the morning is commencement of the nautical twilight, and the beginning of the suitable period in the evening is the ending of the civil twilight.